Okay, hello everyone. Today I will go over a couple of the important things you should have gathered by reading Chapter 10. I'll talk about several of the key issues or several of the key points, and I will do this individually. So I'll have a separate video for each point I talk about. Okay, the first point I wanted to talk about is static variables and methods. What are static variables and methods? Static variables and methods are stored separately from all objects. They are stored with the class. In order to access them, you also have to use the class name. Okay, they have their own chunk of memory. They are not dynamically allocated. Memory for static fields and methods are set aside before objects are allocated with a new keyword. Static methods can only access static fields. Accessing static methods and fields require using the class. The keyword this does not apply, since this only applies to objects allocated dynamically. The keyword this applies to objects allocated with a new keyword. This refers to the current object that is being worked on. So let's go through all of these here. So here I have NetBeans, and I have a class here. It's called instance counter, and I have defined several instance fields as well as static fields. I have a static field called num instances, and then I have two private fields which are not static. I have a static method, getCount. I have another static method, keepTrack of instances. That will increment the number of instances that are created. Okay, and then I have a constructor, instance counter, which when that constructor is called will call the static method keepTrack of instances, which increments the number of instances by what? I have another constructor which takes in a random string and number, and that will assign that to the instance variables a string and a number. Okay, and again, this constructor as well as the constructor above, those will be the constructors when we create new objects, not a new object. And so each new object will get the instance field a string and the instance field a number. But each new object will not get the static fields, or it will not get num instances. It will not get getCount. It will not get keepTrack of instances, okay, because those are static fields and methods, and they belong to the class. So each new instance will not get access to those. But when a new instance is created, it will call the method keepTrack of instances. And then I have a method that's not a static method, so print this. And it will return, so when it says return this, it will return the memory location of the object that's being called. Okay, this refers to the current object being worked at, and this will return the memory location, and I'll show you that. And then we have another static method, again, update num instances, and that will increment the number of instances by whatever is passed into the parameter in the function. Okay, so here, let's begin this. Again, this is demonstrating static methods and fields. So initially I starting with instance counter, getCount, number of instances. Okay, so when this application is run, the static fields and methods will get allocated first. Okay, so initially there will be no instances. Okay, ignoring line 51 for a minute. So this line 53 was a for loop, and it's going to create actually 5 new instances of instance counter. Now again, each instance will only receive the non-static fields, or the instance fields, a string and a number, in the non-static methods. I am not assigning those instances to a reference variable, so you see it's highlighted there yellow. Basically, I will never be able to get access to those instances created. Okay, but for my purposes, I don't really care. I just want to illustrate static fields. And then what I do is I will, so that will be 5 instances created. And then what I will do, I will create an instance of instance counter using the other constructor on line 30. So passing in a string and an int number. But now I'm going to get access to, I'll create a reference variable to those, and then I'll be able to get access to them. So and then I'll print out a created instance counter get count plus instance. So it should print out 7. I will create 5 instances from the for loop, and then I will create 2 more instances of instance counter. Okay, so let me run this. And it says starting with 0 instances and created 7 instances. Okay, so I want you to notice though that so when I created those instances, the constructor always incremented the number of instances by 1. It called the keep track of instances. So it incremented that by 7. Now notice again, even though I created 7 instances, okay, there's only one num instance. Okay, it's not that I created 7 num instances, there's only one in static. Right? And then what else did I want to demonstrate? Again, where is this? So let me go to a non-static method. Public instance counter print this. Return this, that's non-static, and let me, okay, so really this is the only non-static method I have. Now each of those 7 instances did get this method, print this, and it's returning this. So now I'll show you. If I go system out print, so system, oh, one thing I did want to show you again, each instance will get the non-static fields. So if I go, well, let me do this. This would be better to show you. Okay, so I'm going to print out. So if I go system out print line, and then so object 1, and then print this. Okay, and now we'll print out. So this again refers, and this gets into the other thing I wanted to talk about, the keyword this. So this always refers to the object in memory. Okay, and now if I run this, then it's going to print out. So you see it says instance counter, and it's printing out the memory location of the object in memory. This keyword always refers to the object in memory. It does not refer to this class. Okay, it does not. I created a new object of type instance counter, and that's what it refers to. And the other thing I wanted to show you, if I do this, I want you to notice though that I only have access to a number and a string, and print this because those are non-static. Those are non-static fields or methods. Okay, those objects I created in memory with the new keyword does not have access to static fields or methods. All right, And is there anything else I wanted to show you about static? So let's take a look here. Okay, they have their own chunk of memory. They are not dynamically allocated. Static methods can only access static fields. Accessing static methods and fields require using a class. And the keyword this does not apply. Okay, so accessing static methods and fields require using a class. So let me go back to here then. Okay, so if I wanted to print out, okay, so let's see here. Public static void keep track. If I wanted to print out num instances, okay, I'd have to refer to the class. So this is the class's instance counter. Now I could, so now if I wanted to print that out, so now I could see in order. So again, this says here that accessing static methods and fields require using the class. So I had to use, instance counter because that is a class, and then I can print out num instances, which again should be, I have 7 of them, right? Yep, created 7 instances and 7. So that's static, and then I'll also demonstrate how objects you create. So I want you to notice here, though, the object 1 and object 2 and the 5 instances I created here, they are instances of instance counter. Okay. So if there's anything else I needed to show you about static. Okay, so again, just to recap. On the keyword, this does not apply since this only applies to objects allocated dynamically. So where do I have a static? I have a static method here, update num instances. And where's my other static method? Keep track of instances. In another static method, which I'll use again, count. But I want you to notice here, I'll never be able to use a keyword this. Okay, I'll never be able to use a keyword this in any of those methods because this can never be used with a static class. This applies, you're accessing an object that has been allocated dynamically. With a new keyword, this applies to the current object in memory that you're working with. All right, so that's kind of like an overview of static.